The last type of probability that we need to talk about is an or situation. So we've worked with an individual probability, we've worked with an and situation, now we need to work with an or situation. And when we're doing this, we're going to be adding probabilities. With this, there's some criteria. So before we talked about independent versus dependent. With adding probabilities, we need to talk about mutually exclusive versus inclusive. Okay, so mutually exclusive. With mutually exclusive, this is when the two events can't occur at the same time. Okay, so this might look a little fuzzy right now, but I'm going to give you the formula for this. Again, I know it's a little fuzzy right now. You're not exactly sure what's going on. So my formula, I'm going to add my two probabilities, probability for A, the probability for B. So for instance, I have a bag of marbles in which I have 5 blue, 2 red, and 3 white. With this being said, I want to know the probability of selecting a blue or white. Okay, so what we need to do, we need to break this down in what's the probability of the blue, what's the probability of our white one. So the probability of the blue we know is 5 over 10, or 1/2. So let's find the probability of the white one. The probability of the white one is 3 over 10. So what does that mean? So I'm going to go ahead and add these two probabilities together. Okay, so we're going to make a line here. So the probability of the blue was, I'm actually just going to leave it over 10, just because it'll be easier for addition. I'm going to have 5 over 10 plus the probability of the white is 3 over 10. When you're adding fractions, remember you have to have the same denominator and you add only the top. So I have 8 over 10, and I can reduce that to 4 over 5. Okay. Again, mutually exclusive. The two events cannot occur at the same time. So there's an or there. So I can either select a blue one or I can select a white one. I'm only selecting once, so those two events can't occur at the same time. Okay. So let's say that I have instead I have a deck of cards. Just a helpful hint, there are 52 cards in a deck. And there's 13 of each suit. Let's say that I'm looking for the probability of a 5 or an ace. Go ahead and calculate that. So if I'm looking at this, the probability of a 5 is 4 over 52. The probability of an ace is 4 over 52 as well. So I need to add those two things together. That gives me 8 over 52, but I need to reduce that, in which I can reduce that down to 2 over 13. Okay, so this one was mutually exclusive, mutually exclusive because I could not have, if I'm selecting a card, a 5 is a 5. It's not going to be an ace. I'm selecting one card. I either get a 5 or I get an ace. Okay. So let's talk about what an inclusive event would be. So an inclusive the event could potentially happen where something is getting counted twice. Okay. By definition in the book, they say that it is, well, they don't actually give a true definition, but you are overcounting a situation more than once. With this, you have the probability of the A, you have the plus the probability of the B. So this is, right now, this formula is the same as mutually exclusive, but I'm going to subtract off the and. All right, so this looks goofy. You're not sure what this means. Let's go back to our cards. Let's say, for instance, that I want to look at the probability of drawing an ace or a heart. Okay, so here's what I mean by I know that this is inclusive. For an ace, I can have a heart ace. I can have a diamond ace. That doesn't really look like a diamond. I could have a club ace. And I can also have a spade. See my drawing skills on this one. Not so good. Okay, but you get the point. But for the hearts, I could have one through an ace. So this heart of ace, this ace of hearts, sorry, that's counted twice. That's what I'm talking about. So I'm going to calculate the probability of an ace. That's 4 over 52. The probability of a heart is 13 over 52. So I'm going to add these together. Which I get, sorry, got to add it up. I didn't do that yet. Gives me 17 over 52. But according to my my formula there, I got to subtract off the one that I counted twice. So I double counted this ace of hearts. So I'm going to subtract off. I'm going to subtract off that 1 over 52. And some of you are probably asking, why is it 1? Because there's only one ace of hearts. So I have 16 over 52, which can reduce to 4 over 13. Okay. So we're going to do another one of these. For instance, actually you guys are going to do another one of these. I have a 6-sided die. I want you to calculate the probability of getting a 2 or an even number. Well, to start off with, I know for sure that this is inclusive because 2 is even. So that means that 2 would be counted twice. Okay, so I need the probability of rolling a 2. Six-sided die, so that probability is 1 over 6. Now I need the probability of an even. What is the probability of rolling an even? That'd be 3 over 6. Okay, so I'm going to add these together. And get 4 over 6. Well, what is the probability of getting a 2 that happens to be even as well? That'd be 1 over 6, so I'm left with 3 over 6, which equals 1/2. So the key here is to figure out, okay, do I have something that can be overcounted or counted twice? If you have something that's counted twice, you're going to subtract 1 off. If you don't, then you're good to go and you're mutually exclusive. We'll talk about some different situations. I think the cards are a good one. That's something that can be double counted or not. I also like the dice because of that same reason. So I will talk to you guys about this tomorrow in class.